Hey, and welcome back for part 2. Now, these next 2 examples are going to get crazy. Wow. All right. And so it's a lot of algebra. It's algebra you probably haven't seen in a while, and it's stuff that's good for you. It's like eating broccoli, guys. All right. It's good for you, but it's just going to taste bad on the way down. Okay. So here we go. So sometimes you're given this problem, you got 2 sine squared x plus sine x and then minus 1 is equal to 0. Good news is, again, they're only looking for, answers in 0 to 2 pi. But how do I treat these? Remember, I've always been saying treat sine, your trig function as a big giant variable. So this time I'm actually going to do something about it. I'm going to come over here and I'm going to say, you know what? I want a to equal sine, not sine squared x, but just sine x. So that means if I were to come over here and rewrite this, this would be now 2a squared plus an a minus a 1 is equal to 0. Now that I have this, now this is something more that I can factor. So when I go through and I factor this, I'm going to go ahead and get 2a minus 1 times an a plus 1 is equal to 0. So now I've got like 2 separate problems. All right, now that I have 2 separate problems, again, I remember that means that either 2a minus 1 is equal to 0 or a plus 1 is equal to 0. When I do that, I go ahead and I say, I'm at a point now where I can go, I don't want a anymore, remember? Well, I can just solve for a. I solve for a is equal to 1/2. A is equal to a negative 1. But remember, I don't want to solve for a. I want to solve for sine, or x. And so what does that mean? It means I come in and I replace a with sine x. So now I say, well, sine of x is equal to a 1/2, or sine of x is equal to negative 1. And so when I do that, I've got my different possibilities. Where is sine of x equal to 1/2? Again, using unit circle. You see that is going to be x is equal to pi over 6, comma, 5 pi over 6. And the other one then is, well, what about when sine x is equal to negative 1? Well, sine x is equal to negative 1 at 3 pi over 2. And those are your 3 possibilities. Wow. It's a lot, but not too bad, right? So when you're going to use this trick of actually substituting in, it's when you see the same function, same trig function, sine, cosine, tangent, whatever it may be, but one of them's squared, one of them's not. Then you ought to use this. All right. So now the next question is, well, what happens if I have something that's like this? The next example where I have cosine squared x plus 3 sine x minus a 3 equals 0. What can I do? Well, this is where we take a deep breath and we remember, hey, we have those other, the Pythagorean, all those trig identities. And what we're going to use here, we're going to use a trig identity to try and get everything in terms of one function, one trig function. And so what I do know is that cosine squared, remember we had, hey, there's that Pythagorean identity of, sine squared x plus cosine squared x is equal to 1. Well, that means cosine squared x is equal to 1 minus sine squared x. So I'm able to say, hey, 2 times 1 minus a sine squared x plus a 3 sine x minus a 3 is now equal to 0. I multiply by 2. and combine things. It says 2 times 1 is 2. I'll just write it all out. 2 minus 2 sine squared x plus 3 sine x minus a 3 is equal to a 0. And now I can go ahead and combine some like terms. So 2 minus a 3, so now I have a negative 2 sine squared x plus a 3 sine x, and is a negative 1 equals 0. And again, now you'll be like, oh, hey, I could just go and do what I did before. But before we do, here's what I'm going to suggest. I never like negative numbers being in my leading coefficient. I never do. And the reason why I don't is because it's really hard to factor. It's always been hard for me to factor. So here's a trick. My trick is I want to multiply everything by negative 1. When I do that, I end up with 2 sine squared x minus a 3 sine x plus a 1 is equal to 0. And now I'm going to go ahead and factor. Now I could go ahead and change it out to a's and b, or a's again like I did last time. But I'm not going to, in the essence of saving you guys some room. So when I have this set up and I multiply it out, or not multiply but factor it out, I have here 2 sine x minus 1 times a sine x minus 1 is all equal to 0. And so what does that mean again? Again, I have here that sine of x is equal to a positive 1/2, or sine of x is equal to a positive 1. Well, I just found out the answers for the positive 1/2. That's x is equal to a pi over 6, comma 5 pi over 6. That was in our previous one. And the sine x equals to 1, again, unit circle. Find out where sine of x is equal to 1. That happens when x is equal to pi over 2. And those are my 3 possibilities for that one. Okay. Again, it's not just finding one answer, it's 3, 4, 5 answers. More than likely, for the ones that I'm going to be asking you to do, it should be no more than 3 or 4 answers. Okay? And now you might be like, oh, hey, how do they do this with word problems? I'm glad you asked. So let's take a look at a word problem. Okay. So here we have an Olympic skier, aerial skiing competition. Have you ever seen that? Where you guys go hit the jump, do flips and twists all in the air and come back and land perfectly on their skis, and you're secretly hoping they crash and burn so that you can watch that over and over again on YouTube. But so there's a formula for finding out when this person is going to reach their maximum height. This formula is given by this set here. So I want to walk through this. They said g is the acceleration due to gravity, or 9.8 meters per second. That means they're already telling you that g is always going to be 9.8 meters per second squared. If you've taken physics or IPC, this is something that you should know. Okay. Part A is saying that if a skier obtains a height of 5 meters, that means that his h peak, so for part A, they're saying my h peak is equal to 5 meters. That may not sound like much, but that's pretty close to 15, 16 feet in the air. That's pretty high up. What was the skier's initial speed? What this problem doesn't tell you is what is initial speed. V naught is equal to initial speed. So if I were to just plug in what they tell me, all right, so I plug into my formula. My formula says that this is 5 meters is equal to V naught, which is what I'm trying to find, squared, times sine squared of theta. But what's theta? Ooh, great question. Here's theta right there. of 58 degrees all over 2 times 9.8. Not squared, not whatever. It's not an S, just so you know. That's a 5. And now this just becomes an exercise of multiplying both sides by, 19.6, so you can cancel out. Dividing by sine squared 58 degrees. So using my calculator, I find out that V naught squared, is equal to 136.265. 136.265. Take the square root, and that's going to be 11.6. V naught, 11.6. And then what's velocity measured in? Meters per second. That's pretty quick, right? How do I, 11.6, that's, 30, 40 feet, 35 feet in a second as you're traveling on your skis. So, all right. So far, so good. Soak it in for a second. If you're not following from this step to this step, shame on you for not having enough algebra. All right. So let's do part B. This here, use the answer from part A. So I'm going to use this answer to determine how long it took for the skier to reach its maximum height if T peak, what do you think the T stands for? Time. T peak is equal to time. Okay, so that's what they want me to find. And they give me V naught sine theta g. So I just plug everything in. So my T peak is going to equal V naught 11.6 times sine of theta, which was, we said was 58 degrees, all over 9.8. I go ahead and plug in my calculator. I find out that T peak is equal to 1.009 seconds. Great, found an answer. But if you take a moment to think about this, in less than, a little over a second, he went from being on the ramp to being 16 feet up in the air. Shh. How cool is that? And you were able to find that out using the math. Now here's the deal. These next two examples that come after this, I'm going to do in class. Okay? They require the use of a calculator. I want to do these with you in class. I want you guys to look at them and see them and how I use the calculator in class. And we'll walk through these together. It'll take up a good 10 minutes on the calculator. So I look forward to seeing you guys tomorrow. Bye.